Well, good afternoon. It's great to have everybody at our human spaceflight panel this afternoon. My name is Steve Cook. I will be your moderator for the next couple of hours. I was with NASA for 20 years at Marshall Space Flight Center and ran the Ares program before I left, and I've been in private industry at Dynetics in Huntsville, Alabama ever since. Given my background and interest, I have a lot of longing for the subjects that we're going to be covering today. My heart definitely is in this, is near and dear to this topic. And our topic again is human spaceflight in the United States, both government and commercial led. You know, there's been a lot of discussion over the past decade in particular over government and commercial space systems, and we have representatives from 6 space systems which are in development and are just a couple of years from launch in a couple of different venues. We have a very unique panel today. Typically, we have commercial on one panel, commercial led on one panel, and government led on another panel. And we decided to make this more interesting given we're moving closer and closer to flight, and given that the future is where these two communities are tied together at the hip, putting all this together, it would make sense to have these leaders together today. So I welcome them all here and appreciate their taking their time out of their day to be on this panel. We've got a lot of things to talk about in the next 2 hours. We want to make this a dialogue. I don't want to make this won't be a one-way from anybody. We're going to come to the audience for some questions, probably every 3 to 4 questions. I'll turn it to you. I would appreciate not having crickets the first time I throw one out. I'm sure you guys will give us some good ones. It's a small enough room. We don't have a separate mic, so just holler out your question and speak loudly. But please say who you are and who you're addressing the question to, whether it's multiple folks or whether it's just one, in terms of how we go this long. I've got a couple of secret plants in the room, and I'm looking for you guys to make sure you ask a question if we don't get one as we go along. Anyway, now let's get on to our panel. Let me introduce the panelists today. First off, Mr. Todd May. Todd is manager of NASA's Space Launch System program at Marshall Space Flight Center. In this role, Todd supervises a nationwide team developing America's next heavy lift launch vehicle for deep space exploration and science. Prior to his work with SLS, Todd oversaw and helped manage numerous robotic and human spaceflight efforts, including the Lunar Reconnaissance Orbiter, the Lunar Crater Observation Sensing Satellite, the Chandra X-ray Observatory, new propulsion technologies, the ISS Airlock, Gravity Probe BREE, and the Discovery and New Frontier Program Office. Todd earned his bachelor's degree in materials engineering from Auburn University and completed all of his coursework for his doctorate in materials science. His many awards include NASA's Exceptional Achievement Medal, the Senior Executive Presidential Rank Award, and NASA's Outstanding Leadership Medal. He recently accepted the Rotary National Award for Space Achievement in recognition of the SLS team's many accomplishments. To Todd's right, we have Mr. Mark Geyer. Mark's professional experience includes manager of the Russian Elements team for the International Space Station, manager at the International Space Station Integration and Program Office, manager of the Systems Engineering and Integration for the Development Program Division of the Exploration Systems Mission Directorate at NASA headquarters, and deputy program manager of the Constellation program. Since 2007, though, Mark has been responsible as the NASA program manager for the Orion program, where he's responsible for day-to-day program management, development, and integration of the Orion system, crewed exploration system. Mark's an Indiana native who received his Bachelor of Science in Aerospace Engineering from Purdue in 1982, and he also performed his graduate studies at Purdue University, earning a Master of Science in Aerospace Engineering in 1983. Throughout Mark's career, he's received multiple awards showcasing his skill and work ethic. He has been honored with the NASA Exceptional Service Medal, the Spaceflight Leadership Award, the NASA Outstanding Leadership Medal, and the NASA Meritorious Executive Rank Award. He was also a nominee for the Federal Engineer of the Year of the Award in 2012. Mark Geyer. Next to Mark is Mr. Mike Bolger. Mike is the manager of NASA's Ground Systems and Development Operations Program at the John F. Kennedy Space Center in Florida. It's his job to put these two guys' hardware together and launch. Appointed to this position in April of 2013, he is responsible for leading the government and contractor team that is preparing the ground systems, infrastructure, facilities, and processes required to support NASA's next-generation space launch systems and spacecraft. Bolger began his career in 1987 as a software engineer supporting shuttle processing at Kennedy. He later managed a project controls office and acted as the contracting officer's technical representative for the $2.8 billion Joint Base Operations Support Contract. In 2006, he was named the CIO and most recently spent 8 months as acting deputy director of the center. He graduated also from Indiana, but Indiana University in 1987, so we have to keep these two guys apart. We start talking about basketball with a Bachelor of Science in Computer Science and a minor in Mathematics. He earned a Master's in Business Administration from the University of Central Florida in 1999. To the right of Mike is Garrett Reisman. Garrett is responsible for working with NASA to prepare SpaceX's Falcon 9 rocket and Dragon spacecraft to carry astronauts. Garrett's experience as an operator of both American and Russian spaceflight hardware will help SpaceX in the development of human interfaces and controls, displays, seats, suits, and environmental control systems. If you need to know Russian, just hit up Garrett afterwards. I understand he gives special tutorial lessons. Garrett came to SpaceX from NASA, where he served as an astronaut starting in 1998. He has flown on 2 space shuttle missions, during which he logged over 3 months in space, including over 21 hours of EVA and 3 spacewalks. Dr. Reisman served with both the Expedition 16 and 17 as a flight engineer aboard ISS. Garrett holds a BS in economics and a BS in mechanical engineering and applied mechanics from the University of Pennsylvania, and an MS in mechanical engineering from Caltech and a PhD in mechanical engineering from Caltech. He is an FAA certified flight instructor. To Garrett's right is Mr. John Mulholland. As Vice President and Program Manager of Commercial Programs, John leads Boeing's efforts on commercial crew and cargo programs, including the work on the Commercial Crew Integrated Capability, or CCI CAP, Space Act Agreement. John ensures that proven innovations and capabilities from across Boeing are used in the development of space transportation vehicles to support NASA and other commercial customers. Prior to his present position, Mulholland was the Vice President and Program Manager for Boeing's Space Shuttle program, responsible for overall direction and successful execution from January 2008 until August of 2011. Mulholland led Boeing in its role as the major subcontractor to USA in support of its operations contract. John is also a National Exceptional Achievement Medal recipient and is a graduate of New Mexico State University with a BS in Chemical Engineering and a master's degree in Mechanical Engineering. And to our far right, Mr. Mark Sarangelo. Mark leads Sierra Nevada Space Systems, a producer of satellites, space transportation vehicles, propulsion systems, and space subsystems. Mark was formerly the chairman and CEO of Space Dev Incorporated prior to its merging with SNC. Mark's industry board memberships included being the chairman emeritus of the Commercial Spaceflight Federation and the founding chairman of eSpace, the Center for Space Entrepreneurship. His charity boards include being a board member and trustee of the National Center for Missing and Exploited Children and the founder, vice chairman, and treasurer of the International Center for Children. Corporate and personal awards include the NASA Space Foundation's Technology Hall of Fame, the Defense Industry's Fast Track 50, Deloitte's Fast Track 500, being a finalist in Ernst & Young's Entrepreneur of the Year, and on Inc. magazine's Top 200 Companies. Mark holds a doctorate, MBA, and Bachelor of Science degrees and has been scientifically published and served as an officer in the U.S. military and as a licensed pilot. Let's welcome our panelists today. We're going to start off with 5 minutes from each of our panelists with an overview of their progress and accomplishments to date, and then we'll move into the Q&A. And we'll start with Todd.
Okay. Thanks, Steve. Okay, so our job is to field a rocket for Mark and have it ready to launch in December of 17. From a big picture perspective, in one sentence, we're on track to deliver our hardware to meet a 2017 launch date today. The phase of development that we're in is preparing to get to critical design review late next spring. And we've got 4 major components of the rocket that have to go through their critical design reviews over the next 8 months or so. One of those is complete. We have the board for the second one tomorrow, and then we got a couple more, and I'll go into more detail here in a minute. I'll just walk down through, or maybe walk up through the vehicle, starting with the engines. The RS-25 has its CDR coming up later this fall, and it's really, CDR is a misnomer. The engines are already built, and so they actually are considered a constraint to the systems engineering process for designing the vehicle. We will validate all the interfaces with the rocket and the performance parameters. There are a few things different on this rocket from when they flew on the shuttle in terms of things like we're hitting the lower limit on the inlet temperatures. We've got a higher inlet pressure and things like that. We also have a new controller, and we're writing the software for that. We've actually put the first RS-25 into the test stand down at Stennis. We're waiting on the first development controller, one of these new controllers that's actually based off of the J2X controller and its software before we start running it through its paces this fall. Moving on to the boosters, their CDR is in progress right now. They had their pre-board last week. There were only 77 RIDs written at the entire review, and only 19 of those went to the pre-board. Some subset of those will actually go to the boards. We're only really working one problem on the booster right now, and it's with respect to the installation, the PBI NBR and voids in the PBI NBR. And we're heading towards completing that CDR. We'll have a punch list of things to work off, and then we'll head towards the QM1 this fall. We've actually already tested this motor design 3 times. We hot fired it 3 times, 3 development motor firings. The ICPS up on the top of the stack, this is essentially a modified Delta IV upper stage or a DCSS. We're in the middle of contract definitization on that. We've actually definitized our other 3 major contracts, which represent about 97% of the total cost to our first flight. The rest of this is just getting it squared away with the ICPS itself. With respect to the core stage, which is the real large development of the program, that's where most of our activity is. And it has been going swimmingly now for almost 4 years. I can remember 4 years ago saying we would complete the critical design review of the core stage this November. We completed it last month, 5 months ahead of schedule. We had about 200 RIDs on that one, and I would tell you, no showstoppers. We were all green and yellow all the way up through the board. So the design is looking pretty strong there. The avionics are all in a facility called the CITIF, where we're taking all the boxes in and running the flight software through its paces. We're on our 9th version of the flight software now. That was just released a few weeks ago. Things are looking really good on the vehicle itself. With respect to the hardware and the critical path on the core flows through the buildup of the structural test articles and then the flight units from a manufacturing perspective. The work down at Michoud is going really well. You may remember in the external tank days, we'd have like 30 different stations to assemble that thing. A lot of machinery and a lot of folks to operate it. We've got 5 major machines that make the core structures. As of next week, the 5th and final machine will be up and running. It's over 170 feet tall. It's accurate within 0.02 of an inch. Because we weld up the tanks in the vertical. All 4 of the other machines are up and running today. We've actually manufactured all the rings for the first flight unit, and so they're sitting down at Michoud ready to be integrated onto the cylinders. We have 3 of the 5 structural test article cylinders for the hydrogen qual tank. We need 2 more of those before we put that together. We've got one of our domes, one of our qual domes is ready to go. So the next thing will be actually getting onto the VAC and welding these parts together to make, first we'll do a Pathfinder LOX tank this fall, and then we'll go by the end of the year and have our first hydrogen qual tank come off of the VAC. So things are moving very well there. At Michoud, we're working on the B2 stand, where we'll actually take a full core stage and run it through its paces, firing all 4 engines, full mission duration. That's proceeding on schedule and on budget. And so Stennis is going along pretty well. As far as integrating the entire vehicle, so all these CDRs end up in about the May timeframe next year, coming up to a vehicle level CDR. We're actually working very few systems integration issues right now We solved the loads issues earlier in the spring, and we were down to some acoustic issues. One of the more recent ones, if you see the second picture from the right over there, that's called SMAT, where we do a scale model acoustics test. Some of the reflected acoustics coming up off of the pad have been giving us a few problems there. We're probably going to end up putting a wind placard of about 24 knots and avoiding a flyaway maneuver to handle that for now. So in general, things are going very well technically with the vehicle. The schedule still looks good. Like I said, we've got 3 to 5 weeks on our critical path in terms of slack to deliver the first core to Michoud.
Thanks, Todd. Mark.
Well, let's see. So for Orion, our next we're doing a lot of things in parallel, as I'm sure everybody at this table is doing. Our biggest step next is the flight in December. So December 4th of 2014, we'll be launching Orion on a Delta IV Heavy. Basically 2 orbits, and the main thing is the high orbit is about a 3,600-mile orbit. That gets us about 84% of lunar entry, so we'll be testing the heat shield. So a lot of these pictures on the left, especially the ones on the far right, the last 2, that's the crew module on second to the right picture, and then on the far right is the LAS. Those are flight units, and again, we're finishing the work. Today at the Cape, we're actually finishing pyro installation and putting the back shells on the crew module. We'll do a live sky test with the TDRS satellites at the end of this month, and we'll put the propellant in it, the ammonia in it, and then we'll start stacking it with the launch vehicle. So everything's on plan to launch in December. And again, that test is really about the crew module, testing out the crew module and some critical separation events like the service module fairings and the launch abort separation. A couple things about EFT1. It's much more than a flight test for us. It's actually about 40% rather of the DDT&E getting to human flight. So for example, about half of the flight software that we'll need when we fly people is flying on EFT1, and it is some of the most critical software, like all the entry, navigation, and guidance software that makes sure the capsule enters correctly and behaves as it should, and then all the key pyro events, the parachutes and everything else are a key part of this. The avionics systems are the same on EFT1. We'll add another string when we get to people, and there are a few boxes and capabilities that you only need when you have people, like the displays and controls that we'll add when we have people. But it gives you a sense for how advanced EFT1 is and how it's leading us to the next flight. Of course, EM1 is the next big flight for us, and that's when we're on the rocket on SLS. In parallel with getting EFT1 done, we are going now through the process of finishing or beginning EM1. We're actually machining the barrel now. That is our welding pathfinder, which is the last thing we need to do before we'll do actually the flight unit for EM1, primary structure. We're also in our preliminary design review, right in the middle of it now. We finished the ESA PDR, which, as you know, in EM1, our first flight on SLS will actually have a ESA component. The key part of the service module is provided by ESA. So we're going through our preliminary design review with them and finishing those parts. So we have a lot going on in parallel. A very big year for us, and appreciate being invited to this panel. It's a great time really to talk about how these systems fit together, what their role is in the United States leadership in space, and how we work together to achieve our goals. So I appreciate being invited to this today.
Thank you, Mark.
Yeah.
Mike?
So I guess the first thing is when you get 7 people at 2 tables, somebody's going to get the legs. That's me, so that's why I'm backed off just a little bit. So while Todd and Mark are working really hard to design the launch vehicle and the spacecraft, we're working hard at Kennedy as well, preparing the launch site. So we're modifying our facilities, we're refurbishing assets, and we're developing the ground systems that'll support SLS and Orion moving forward. I was going to give you a quick overview of some of the projects that we have. As I do that, hopefully you'll kind of hear these themes or these driving philosophies of affordability, flexibility, and innovation, because they really are a part of all the projects that we're working on. If you can see the first 2 pictures on the left side of the chart, those are pictures of our vehicle assembly building. That's kind of the iconic Kennedy facility, 500 feet by 500 feet, so 500 foot tall, 500 foot across. It's got 4 high bays, lots of cranes. And each of those high bays is capable of processing a big rocket. And in fact, you could fit a Statue of Liberty in each of those 4 different high bays. The building's that big. But it's also 50 years old, so we're working hard on it. We're upgrading a lot of the systems, the FireX systems, the low voltage, the comm systems, taking out the copper, putting in fiber, working on the big doors that you see there as well. And what we're getting ready to do, and this is in the leftmost picture there, is to build the platforms, the work platforms that allow us access to the launch vehicle and the spacecraft. Because it's in High Bay 3, and that's a picture of High Bay 3 where we actually stack the solid rocket boosters, and we made them with the core stage, and then we put the second stage and then the Orion on top of that. This is where we stack, integrate, and do the initial test out of the rocket. And so those 10 platforms that we're getting ready to build there are kind of neat. And we took out the old shuttle platforms because they were at the wrong heights. We're putting in the 10 new ones, and these things can go up or down 10 feet. So in other words, they can be adjusted. And then they've also got inserts that allow us to conform to the outer mold line of the rocket. And so as the SLS evolves, we'll be able to evolve with it without having to make significant facility changes in the vehicle assembly building. We've awarded that contract. We're 3 or 4 months into it, and we're on track for a spring of 2016 completion in the vehicle assembly building. The picture second from the right is of our Launch Control Center. You can't see it there, but Firing Room 1 is the firing room that we're going to use for our launch processing system development. We're now developing a new state-of-the-art launch processing system. We're leveraging modern computing power, COT software, to give our firing room engineers more data and more capability than they've ever had in the past. We've already developed a basic monitor capability and some basic command and control capability. We still have a lot of work in front of us, though, to develop the redundancy and the safing sequences, and also all the application software that supports test and checkout of the SLS and the Orion. And then the picture on the far right is a crawler transporter. There's a person in that picture to help you get a sense for the scale of the assets. At Kennedy, something you don't realize until you've actually been there is just the scale of all these assets that we're talking about. So that crawler transporter kind of looks like a tank that maybe you'd seen a Star Wars movie or something, right? It's like about 100 foot by 100 foot across. We've been using that since the Apollo program as well. It's used to transport the mobile launcher and the launch vehicle and the spacecraft out from the VAB to the launch pad. It's got a top speed of 1 mile per hour, but we don't actually ever drive it that fast with the rocket on top. We go a half mile an hour, so it's a 3 mile trek. It takes us about 6 hours. Really neat vehicle. We're in the middle of refurbishing a number of the elements of that as well. We're wrapping up right now on roller bearings, which are inside of each of those trucks, which help us roll out. And then we're also getting ready to do the leveling devices. As you go up the hill of the launch pad, you've got to keep the stack perfectly vertical. And so we're replacing the leveling devices that we've got on there as well. Those projects are on track, and we're in pretty good shape. A couple of the assets that you don't see in the pictures there, well, you can kind of see the mobile launcher. It's behind the rocket in the leftmost picture. You can see the tower. But the mobile launcher is the launch platform with the tower and the access arms and the umbilicals. This is the structure where all of our ground systems interface with the SLS and with the Orion. It's about 400 feet tall, so kind of think 40-story building. This mobile launcher was initially designed for the Constellation program for an Ares 1. We took advantage of the opportunity that we had a fairly new mobile launcher that we could modify rather than building a new one from scratch. So we're modifying the exhaust hole since we have a different configuration on the mobile launcher. We're also doing structural modifications. And right now we're about half done with all of the structural mods, both to the platform and to the tower. In the couple years ahead, we will start to deploy the ground systems, which will be the interfaces. So we've got about 2 years of work left to go on the mobile launcher. It's going well, though, and we're on track. Not in the pictures, Launch Pad B, so Complex 39, we're using Launch Pad B. We've got a new clean pad architecture, so now that the tower's on the mobile launcher, we don't have a tower out at the launch pad. So it makes it capable of supporting not only an SLS, but also other rockets someday in the future. So this is part of that flexibility that we're talking about. Out there, we've got new lightning towers that are in place. We've demolished the old flame trench and flame deflector, and we're getting ready to build new ones. We're working on refurbishing our environmental control systems. And again, Launchpad, things are going pretty well, and they're on track. So we're making great progress. We really have leveraged a lot of existing assets from prior programs, and that's really that affordability theme. But at the same time, we've tried to weave in the innovation, like in our new launch processing system or in those VAB platforms that go up or down to help us evolve as the SLS and Orion evolve. So we're only a few years away now. A lot of work in front of us. We're working really fast, and we're really excited to be a part of this program.
All right, Mike, thank you very much. Garrett.
Hi. So it just strikes me as I'm listening to everybody talking up here, what an amazing period we're in right now, because there's so much activity going on across the whole spectrum of human spaceflight. It's been a long time since this much design, development, and test activity has been going on in this arena. And it's really a very special historic period, and I'm just really happy to be a part of that. So it's at SpaceX. I'll give you a quick brief of what we've been up to. It's been a pretty exciting week. Just last Friday, we had another flight of our F9R DEV vehicle. That's the rocket formerly known as Grasshopper. And it went up to it did a 1,000-meter hover test and testing out some new software, some new actuators, and it performed really well. It's always really, really fun to watch that thing fly. If it's not on YouTube yet, it'll be there soon, so I keep an eye out for that. Then just early this morning, we launched a Falcon 9 with AsiaSat on top, and we had a successful launch to a GEO orbit. And that makes Falcon 9 now 11 for 11 successful launches. And it's fortunately the rocket has been performing well. The thing that was really probably remarkable about it was that our last Falcon 9 launch prior to this morning was 3 weeks ago. So our launch cadence is getting quite high. We've actually done better than our once-a-month target that we were shooting for about this time. At least we did over the past 3 weeks. And but we intend to maintain that. We have another launch coming up very soon, the next AsiaSat launch, and then we have another CRS launch coming up right on the heels of that. So we're happy with how the Falcon 9's been coming along. And also this one, because it was going to GEO and it had a pretty heavy bird on top of it, it did not have landing legs, and it used up pretty much all of its gas, but we still did a few maneuvers with the first stage, looking at getting more data for reusability. But the last two previous Falcon 9 launches both attained a soft landing in the ocean, a soft splashdown of the first stage. And we're really getting very, very close to bringing one of the first stages back and putting her down on either a barge or on some dry land. And we're getting very excited about flying a first stage, a reused first stage for the first time, and we think we're not too far away from that. So that's what's been going on our Falcon 9 side of the house. On the Dragon side of the house, where we're working on cargo, we've just had our 4th successful cargo flight up to the ISS, and we're about to launch another one here in a couple months in September. But most importantly, and near and dear to my heart, because it's what I do. we're making a lot of progress on converting that cargo vehicle to carry people. So in the CCICAP program, in partnership with NASA, we only have a few milestones left. We are working our way through our CDR, which we've segmented into different parts. Our next one will be just 2 weeks from today. We'll be having our operations critical design review. And in there, we're going to be talking about, amongst other things, our launch operations, including all of our plans for 39A, the launch pad at KSC, which we have at least 4 now that we'll be launching our human spaceflight missions out of. And that's a big honor for us because, I mean, that was the pad where Apollo 11 launched, and it's the pad, maybe less notably, but maybe more importantly to me, where STS-123 and 132 launched from. So, so it's a special place. And so we'll be doing that. This month we'll also finish our structural qualification of all of our primary structure of the spacecraft. That's been going well. A few hiccups here and there, but we plan to wrap that up and complete qualification testing this month. And then that leaves us with a few more CDR follow-ups, but after that, really the two big e-ticket tests, which are our pad abort tests and our in-flight abort tests. And that's coming up later. The pad abort is scheduled for November. The in-flight abort test is scheduled for January. And that's where we're really going to ring out the abort vehicle. The test article is in manufacturing, and actually it's approaching final assembly. All the primary structure is complete. We're just about to mate the service section to the primary structure, and that has all the propellant components on it. And then after that, we'll be assembling the thermal protection system. All those panels have already been completed and fitted up. In fact, if you saw the unveil of the V2 Dragon that we did very publicly not too long ago, the exterior of that was actually the TPS panels from the pad abort test. The interior of that was actually the structural qual test article. So it served a dual purpose for a couple weeks as a marketing tool, but it's all flight hardware. So we're going to put that together, and then we're on track for that November pad abort test, and we're going to recycle the same test article and use it for the January in-flight abort test. That we're going to do out at Vandenberg. So we got all that going on, and obviously all three of us are sitting there waiting to hear from NASA, hoping that we will get a starring role in the next production, which is CCTCAP, and take this on to the next level. But whatever happens, we're pressing ahead and just happy to be part of this really historic period of human spaceflight in America.
Thank you, Garrett. John.
All right, thank you, and congratulations for last night, Garrett.
Thanks,
It was wonderful. So July was a big month for us. We finished off all of our milestones that we had laid out for CCICAP with the completion of the Phase 2 spacecraft safety review and then the critical design review. Incredibly important for our team to meet that performance to plan metric that we laid out. Really helps us reduce the risk going forward. One of the biggest risks we have in any development program is traveled work. So mitigating that risk really set the team up to get ready for the next round, depending, as Garrett said, on how this month goes. Looking at the four major design segments, the first and the largest, obviously, is the launch vehicle. And Mark and I are both on an Atlas V launch vehicle. And they're closing in on 50 launches with 100% mission success. So unparalleled mission assurance and schedule certainty from that launch vehicle, which is really important from our standpoint for crewed flights. The two big areas of design work on the Atlas V were the crew access tower and the emergency detection system. And in partnership with ULA, we've gotten to full engineering release on both the tower and the EDS, and in fact have ordered the material to start building the tower early in the next round. On the CST-100, again, a lot of design maturity progress on the capsule on both the service module and the crew module. We're at over 90% engineering release by mass on both of those, so tremendous progress on those. Flight software, we've got 3-string flight software released and tested, both in the engineering or the software lab, as well as the training simulator that we have. So a lot of progress across the board on all of the IPTs. We've got well over 100 pieces of flight hardware that already have been delivered, getting ready for the structural test article that we will be assembling early in the next round. And then moving on to the ground systems. One of the items that we chose early on was to embed the Mission Operations Directorate in our team for the plan, train, fly portion of the mission. That was largely due to the expertise they have and to drive down overall system risk. They're the only entity or only domestic entity that have done plan, train, fly for human spaceflight missions. So having them embedded in our team and has helped our team progress quite a bit faster. So a lot of the training products have already been laid out. And then the last item is the OPF-3, or the old OPF-3, where we're in partnership with Space Florida right now, going through refurbishment of that building, where we'll do all the assembly, integration, and test of our spacecraft. The nice thing about that facility, obviously, is the uniqueness of that facility, the co-location near the launch vehicle, and also the tremendous resources that we have, trained tremendous resources out in Florida for the assembly operations. So everything's progressing well, and we'll be building up the structural test article early in the next round.
Great. Thank you, John. Mark?
It's good to be at the end of the table, right? I can just say I'm doing all the things these guys are doing. I did notice, though,
Perfect.
that we still have NASA on one side of the table.
Yeah.
Next time we have to mix it up, right, guys? It's a really terrific time, as my colleagues here said. We are, maybe you can move the slide up, too. I can brief John's slide up. if you want.
I thought about putting John's up for Garrett, but I decided that wouldn't go over real well.
I can brief that one, too.
CST 100 has got a certain a little humor amongst us. We talk a lot. We're friends, and one of these times where we said we're going to all switch up our pitches so that we do each other's pitch and see how that turns out. I'm really thrilled to be here to talk to you about what we're doing, and I think mostly because we're a hardware company and we're getting to build and fly real hardware. It's a great time for us in many ways. It just highlights some of the things that have been going on this year. It's been such a busy year. We have built our first flight vehicle. As many of you know, we started the flight test program at the end of last year. That program is entering its second phase this year. We'll be doing both uncrewed and crewed flights over the next year, and that's a really special thing for us. That vehicle essentially for us is our enterprise in terms of a shuttle. It's meant to do atmospheric flight tests. It's meant to do a series of those, and then it'll move on to the orbital vehicle. So we're flying, and we're testing. In addition to that, last week, some of you may have picked up, we have already started the build of our orbital vehicle. That started being built down at the Michoud facility in partnership with one of our strategic partners, Lockheed. And we've delivered the structure, and last week we introduced the structure at the Lockheed facility in Fort Worth, which is where they build the Joint Strike Fighter and the F-16. So we're well on the way of building the second vehicle in the fleet, the orbital vehicle, the first vehicle that will go to orbit. We have acquired and announced our first launch, which is November of 2016. As John mentioned, we're flying on an Atlas V, and that launch slot is now settled. It's pretty exciting. A little over 2 years from now, we'll get to go to orbit, and that first flight will be an uncrewed autonomous flight. The vehicle is what we call optionally piloted, which means it's fully autonomous and fully piloted in the same architecture. So we will be doing one autonomous flight, and then the second flight will be a crewed flight, and that will bring us through certification. So it's really pretty fun to be able to see real hardware after many years. Some of you know this project started for me and us here in San Diego, so it's a special time to actually be back here for this, to see from that concept now 9 years ago that we're actually in flight. Beyond that, there's from the program, we are 92%, 93% completed with ICAP, and we've actually done some additional work, which means that we've entered into CDR, which was not part of our plan. Our 15th milestone will be done here in the next couple of weeks. So that's well on its way and doing quite well. We finished, as I think all of us have done, but we finished our certification plan early, which means that we're on the process and the steps to getting certified, and that's a big step for us. Beyond that, we have really, tomorrow morning we'll be releasing for the first time the press release that will be highlighting the expanse of our team that we've been building. And we've taken a very definite approach. When I first started this, we said, let's go out and build together the best team we could find. We call it our dream team, the best companies, people in the industry, organizations in the industry, and it really has exceeded even beyond my expectations. Currently, we have over 30 companies engaged on the program, from very large legacy aerospace companies to medium-sized companies to a whole group of small and disadvantaged companies. We were a small company once, and we understand how tough that is, and we've opened up slots on the program for that. There are now 9 universities helping out Dream Chaser, and we have reimbursable Space Act agreements with 9 NASA centers, so we're getting the benefit of the people and organizations around NASA. Beyond that, we have been fortunate in that we've been able to reach out to the world, and in a very similar way to how the ISS was put together and the partnership behind that. We now have signed agreements with the European Space Agency, the German Aerospace Center, and just a couple weeks ago, JAXA. In total, that group represents 21 space agencies that are now on board in our program. So it's quite the team, and those of you will see who come out in the press tomorrow, really for the first time for us. And we're very fortunate in that regard. And I think just lastly, I just want to reach out and say thank you to NASA. This is, I think all the companies who are in this process have realized it's a big sea change to get this done. I've been here since the very beginning of this effort, and there was a time where everybody thought that this was a crazy idea. And you could just tell by listening to the progress that's been made here that we've gone an awful long way. All of us have gone an awful long way with not a lot of resources and are building real hardware and doing real things. So it was a change for NASA. We embedded NASA in our company, in our program, and really benefited from it greatly. And it's really a good bilateral partnership between us.
Great. Thank you, Mark. And the one thing I noticed that's unique about Mark and his team, too, if you look over on the left-hand side, have you got the deal cut for Disneyland for a Dream Chaser ride? I mean, that's, talk about reaching out to folks. That's interesting. You got Dream Chaser and Lucasfilm on your team as well.
We do, actually. We've started a relationship with Disney. Disney is looking to the future, revamping what they're doing with space, and we're part of a launch that they're doing for the next Star Wars series in January.
Interesting.
Called Run Disney in Los Angeles.
Great.
So if you want to run around with a bunch of Ewoks and make come in January, you get a chance. There are 32,000 people signed up for it.
Well, Mike's got the vehicle to take them around in from the Cape, so you can fly them around. All right, let's go. What we're going to do now is start off with some broad questions, very policy-oriented kind of questions, and then we're going to delve into kind of statuses and more details in each one of these spacecraft as we go along. So this first question is for all of you, and in the interest of being fair, Mark, we're going to start with you and work our way back this way for this first question. This one is for all of you, and what we'd like you to do is give the audience here your thoughts on the enduring questions that describe the rationale for and the value of human space exploration.
I think for us, we talk about, and all of us are involved in some way in the industry, the shiny hardware that's behind it, and we have a lot of that, and it's really pretty special. But I actually like to talk more about what the space program means. And traveling around the country, talking in many places, I did 100 different speeches this past year, you realize that it's about inspiration, and it's about the next generation of what we do. Very little of what we do is one generational. And I think what we're seeing now is that there's a renewed interest in space. There's a renewed interest in the science part of what we're doing, and the emotional part of what we're doing, and I think the exploration part of what we're doing. And beyond the measures that we do in the scientific exploration and the research that gets done, I think our country and our industry is uniquely provide to that country a spark for what we do next. And we see it in the interns and the relationships we have. We used to think going out to universities was a big deal to help have these young people have an opportunity. What we realized is that we're getting a whole lot more back from this than they are. And they are truly inspiring us to remember why we got in this industry, to remember why this is so important, and to give us an energy and a focus to do things right for the long term, which is an important thing. They're also quadrupling my consumption of Red Bull in the company. It's a good thing.
Great. John?
Yeah, just I think a couple things. One, and we're really lucky, I think, with my generation. I was 6 years old when we landed on the moon. And that really, I think, more than anything, drove me into my career. And I think inspired a lot of people into all kinds of STEM fields. And no matter what industry they ended up, I think that's really important to push that. And I think space, or human spaceflight, does that probably better than any other industry. The second is obviously scientific discovery. And when you look back at our generation and all the amazing discoveries that we've made, they've all been influenced by the effect of gravity. And now with the International Space Station, you're seeing a lot of new discoveries that were made because there was not the influence of gravity and the difference in the physical and chemical interactions that you get. So I think that research on ISS is just going to be astounding over the next decade, and it's going to be incredibly important. And then lastly, our exploration beyond low Earth orbit, and just that need of the human species to explore is just incredibly important.
Great. Garrett?
Well, I think one thing that's become obvious to me in this period is that there is this tremendous hunger and interest in what we do, and a desire to see us take the lead once again in human spaceflight. And it's expressed often in the negative. People are disappointed because the popular perception out there is that we're done, we're walking away from this. And unfortunately, for whatever reason, that's what's out there in the public milieu. And everybody, you know, you're here listening to what we're doing, and you hear about it. Everybody in this room understands all the development work that's going on and all the exciting things that are around the corner, but the general, you know, your average person on the street is not. But I think that's gonna change, and it's gonna be such a wonderful surprise, if you will, for our country, because, look, it's never very sexy when you retool the factory, okay? That's never something that people come by and take tours of, all right? It's when the shiny toy rolls out the other end of the factory that people get all excited. And we're getting very, very close to having shiny toys. And that's what's so exciting about this, and once people see the fruits of all of our labors, and it becomes very public and out there, and they see this roaring back of this country back to the leadership role that it deserves, that's going to be a wonderful, wonderful thing. And the closer we get to that every day by day, the more excited I get about it. So I'm looking forward to the next couple of years.
Great. Mike?
Yeah, okay, thanks. Yeah, I definitely think it's about inspiration. It's about inspiring the people in the United States, and also about increasing their understanding. I mean, we live in the solar system and we live in this universe, and we want to understand what that is, and that means a lot to us. And so getting humans out there and being a part of these exploration programs is a really exciting thing to do. And then the innovation, I think it's kind of what John was touching on a little bit, some of the things that they're doing on the station today. But the innovation that we drive as we try to do these really hard things really comes back and helps in our economy. If you think about, you know, who are the real innovation drivers in the United States, I think certainly you would think of the space program as one of those areas where we really push hard and we really do introduce a lot of innovation, and it really is economically beneficial to us. So I think there's an awful lot of good reasons to do exploration, and again, happy to be working with all these gentlemen to make it happen.
Mark?
Yeah, so I'm almost at the end, so everybody said all the right things. I would say just a couple illuminations of that. I remember, we see great pictures from the robotic missions, which are incredible, but I think it is different when you have a person describe to you their personal experience. You know, like Garrett, when astronauts come back and describe what it's like to see the stars, it's different than seeing a picture, right? They add the emotion to it. I remember the Apollo 8 astronauts going around the moon, reading the scripture, right, was incredibly moving. The picture itself was cool, but just the context they put it in because of their own experience, I think, is different, what makes human exploration different. And also, I think of the multiplicative factor of eventually having human scientists on the ground at Mars, our ability to adapt, our ability to learn quickly, make decisions quickly. Just think of how fast we'll be able to increase our scientific knowledge when we have those experts actually on the ground making decisions every day. And then I would say a much more economical impact, what we don't see a lot, but great discussions about the factories. Think of all these companies now that are driving the manufacturing base. For example, on Orion, at one point, we had work to all 23 titanium manufacturers in the United States making pieces for the heat shield, right? Driving those companies, and these are hard pieces to make, coatings and other things. It drives the state of the art in manufacturing that then helps the overall industry have this capability in the United States, which is really important for the United States to have that. So I see a lot of different things that these programs drive.
Todd? It's on.
Okay, thanks. Well, so I'll try to say stuff that folks hadn't already said. You know, I think one of the things that strikes me is when you think about various people through history, there's always been this idea of exploration and a need to push and explore and go further. Kennedy said it in his Rice University speech. He quoted Mallory when asked about Everest and why he went, and he said it's because it's there. And I think it's just 3 words, but I think we all get it. When we hear that, we understand what that means. I had a chance to work pretty closely with Alan Stern, who's the principal investigator on the New Horizons mission, and he told me two stories that I think also kind of paint the picture. One is that when he was still in grade school, he went to Michoud and actually saw LBJ speak behind the back end of a Saturn vehicle, and he knew that day he wanted to do something in space. Later on in his career, he talked about finding a set of planet stamps, and the one under Pluto, it simply said, not yet explored. And so as Alan was developing the New Horizons, every time he gave that talk, that was always his first chart, not yet explored. And so whether it's with our bodies or our minds, this idea of needing to explore and to push, it really came home to me. I had an opportunity to be in the control room when the Phoenix Mars lander landed on Mars, but the next, actually early that morning, I flew down to Arizona and went with Peter Smith and his scientists, and when they were sitting in a small conference room, maybe a fourth the size of this room, and the pictures started coming from the North Pole, they were all crying, every one of them. It really, they were seeing a landscape no one had ever seen before, and it hit me at that moment that that's what exploration is. And I think what we do here, whether it be NASA or our commercial partners down here on the right, or any one of these folks, is we provide the possibility of exploration. Whether it's the principal investigators, whether it's the folks building the rockets and talking about going to Mars, whether it's the folks at NASA that build the Hubble, the Chandra, the James Webb, and the promise to look out to the ends of the universe, we provide that. And so I think that enduring desire and need to explore is there, and that we help connect that desire to reality. And I love the analogy of the shiny toys. You know, we on the SLS world, we kind of say a lot, we got our head down coloring, and we're the Northwestern Mutual of Space. We really like to kind of keep our mouth shut and just get things done. And I think one day, when the shiny toys come out, it's going to be very exciting in terms of what we're bringing to the table as well. So. So I think it's there, and I'll end with this. We had a NASA Day on the square where we just had the public come from around Huntsville, and I walked up to this little kid comes up, and he has a jetpack on his back that he has made himself, and he actually had a little button on it that you push, and little propellers go on the bottom. And he walks right up very confidently, looks me in the eye and says, "How far is NASA from here?" And I said, "It's about 6 miles over that way." And he said, "You think I can make it?" And I thought, we got this kid, right? He's 20 years from now, he's going to be Bezos or Elon Musk or one of these kids who's always dreamed of that. He's going to go be successful, have money, and want to be part of this and do it. Or he's going to be an astronaut, or he's going to be one of these principal investigators. So they're out there. We just got to keep doing what we do and do it well.
Good answers. Good. That's a big picture question. One of the things that we have, I think everybody in this room, and I know everybody at this table, has personally struggled with is how do you ensure continuity of direction? You know, this country went through a very tough step function change after Apollo transitioning to shuttle. We went through a tough step function change when shuttle, which was going to translate into Constellation, didn't go quite the way everybody expected, but now is translated into the programs that we're talking about today. We've obviously got another election coming up, and elections matter. How can we ensure continuity of direction in human exploration when we come up to this next mark, when we come up to 2016? How can we do that? And I'd like to direct this one specifically to, let's go John, Garrett, and then Todd.
Okay, so I think it's largely up to us. I mean, typically you don't see programs that are performing to plan get canceled. Usually programs that get canceled are ones that have started to overrun or their schedules don't support the needs. So I think most importantly, if we perform to plan, then I think these programs will continue on through an administration.
Okay. Garrett?
Yeah, I think that's the key, is success. As long as we keep having success, then I think we'll continue to go down this path. And also just, restating and making sure it's very clearly evident why we're doing what we're doing and what are the benefits to doing the things the way we're doing them. And as long as we keep communicating that and keep doing it well, I think we'll be okay.
Todd?
So of the three that are answering this one, being the government guy and knowing that 100% of my budget comes from the appropriations process, that's a tough one, particularly when on about 4-year cycles there's sometimes an upheaval. Yeah, I remember Von Braun writing about that in the 60s, that sometimes plans change on, and I think he said 5-year cycles, which I didn't understand. But I think the idea is something along the lines of continuing to deliver, do what we say we're going to do. I kind of like the idea of a relatively flat budget without any major ups and downs in it. I remember Ed Weiler, who used to run the Science Mission Directorate, he really tried to group things into fairly big chunks and keep those relatively flat, because he felt like if you're not trying to sell a big up or deal with the people fighting off a big down, you could kind of move along relatively easily. So creating a plan around a relatively flat budget, I think, is the right way to do it. And then our focus ought to be executing and finding efficiencies as we go forward to be able to offset the inflation as we move forward.
Okay.
Hey, could I say something?
Absolutely.
Steve? Okay. All those are, those are really essential, but I don't know that they're sufficient necessarily to ensure continuity. In my experience, when the presidents change, and also when there's a big change in Congress, they're going to do what they want to do. They often, NASA is so visible, especially human spaceflight is so visible. They all seem to, even if they're not big space supporters, they seem to want to put their fingerprint on it and say, this was my contribution to human spaceflight. Hey, let's add the Russians to space station. I remember that. That was easy. The moon. I've been there, done that. I don't want to do that anymore. Okay, all right. So I think all of these are really essential. But I think the other part you need to be flexible, and you need to have systems that can adapt. So I think that's key, and that's what we're trying to do. Is our systems can do a lot of missions. You want to go on an asteroid? We can go on an asteroid. You want to go to the moon? We can go to the moon. And I'm not fibbing or trying to sell. These systems are capable of a range of capabilities, a range of different missions, depending on what the government and the taxpayers believe is their primary focus. Of course, NASA participates in that. We provide rationale. We provide what the benefits are, but in the end, the public's going to decide, or Congress and the president's going to decide. The other part is my experience now, having gone through this twice, both with Space Station and then Constellation, is that you also, as a program manager, you need to not get too worked up about it. You need to recognize your limitation in driving these kind of things, and you need to be ready to adapt. Right? We had to do that in Orion. Right? We were the big part, then we were hated. Right? Then we survived. It's all part of showing how your system still benefits the United States, how it's all part of leadership, and how it can meet the needs of their current strategy. So I think that's really my experience twice, going through that in Station and Constellation. That's really important. We need to do the things we say, but you also need to be flexible, because things are going to change. They're going to change, and stressing about that a lot can be a lot of wasted energy, in my opinion.
I think it's interesting you talked about adaptability and flexibility, both from a hardware perspective, i.e. asteroid, moon, Mars,
Right.
kind of thing, but also from the people.
Yes.
From the people, and then understanding that the public eventually will decide where we're going to go. It's publicly funded largely today. Great dialogue here. So rolling on, one of the things that's often talked a lot about is we're developing these new capabilities, to go out and explore. What is the right balance between what I would call technology pull, where there's a clear requirement, I've got to have something, versus technology push, where I've got research that's going on and it may lead to something new. What is that appropriate balance? And Mark Sarangelo, let's start with you. Let's go to Mike Bolger, and then back to you, Mark Geyer.
I think to start with the balance question is probably to start with what's the purpose of the mission. And in our case, with our orbital low Earth orbit system, we weren't really trying to create new technology there. What we were trying to do is create predictable, lower cost transportation to allow the technology that's in low Earth orbit to be used as much as possible. And I think having that balance and understanding what the mission is, while we've got many new things in our system, we're using a design that has had a lot of history to it. We're flying a rocket that's flown 45 times. We're not trying to create new technology. What we are doing that's new is trying to create a system that's highly reusable, lower cost, predictable, and can allow access to low Earth orbit in a much more stable manner. The purpose of that then is to affect the new technology development that is being pulled on the space station, the work that's being done in medical research, material research, potential of building new space stations. If you have the infrastructure, those things will come. And in many ways, it's very much like the technology industry. We talk about we're building the iPad, and the apps will come once the iPad and broadband is out there. We have predictable launch. If we have good structures that are out there, then the apps, the information flow, the new technology will be developed as a result of that. And we feel like we're helping to build that infrastructure and trying to do that as simply and direct and as efficiently as possible.
Mike?
Yeah, I definitely agree, but the push and the pull side of this are really important. For our mission, there are examples, like I talked earlier with the launch processing system, where the computers have just evolved so much. We're able to take advantage of existing technologies to give information to our engineers in our firing room much easier than we used to be able to, and give them a lot more information. And so we're really taking advantage of some of those push kind of technologies. But particularly for these deep space kind of missions, this idea of innovation, again, is really important, and that's where the pull side of it comes in, as we develop super lightweight materials or miniatures, things we do, and it's primarily on the flight side more than the ground side, but miniaturization, the super lightweight materials, a lot of the things that we're doing that help them block radiation, as we go into deep space, things like that, all ought to then reflect back and provide benefit to us here on Earth. So I think probably the farther away you get from Earth and the more, the deeper the challenges that you're dealing with, the more you're going to be, in fact, pulling rather than pushing. But I absolutely think both are important, and both will continue to be important as we develop these programs.
Mark?
So I'm a program guy, so if I don't need it, I'm not sure why you're spending money on it. That's the way it seems to me, to be biased. But I think I struggle on the technology side, and just as Mark said, the mission should drive the need, right? We have a pretty good idea of what it takes to get to Mars. We should have a pretty good idea of the kind of things that we should be pushing on. But I really like when the programs focus what it is working on. We had some targeted development programs relative to TPS and landing systems when we were trading land versus water, that we knew exactly what the issues were, and we worked very hard on those specific things. We spent the money, was focused, and got the best result. Also, I think there's a lot of technology in the private sector already, computers and other things, that we ought to be pulling that in and then adapting it to our use, and also pushing the state of the art. We have a new network protocol that now airplane guys are looking at very closely, because we needed it. We needed a very secure network Ethernet protocol that works for us. Now they're looking at that. We started by pulling the displays from the 777, but of course they got to handle abort load, so it's a little bit different. So I like the idea of pulling from industry, pulling from state of the art and commercial, and adopting to our needs. And then as we find challenges that we have to overcome, that's where we spend our focus, overcoming those. And often you'll find, just like Apollo did, it'll drive some technology that actually helps on the Earth. So that's my bias.
Great. Anybody else have any thoughts? All right, I know you've been warming up, so let's take our first question from the audience. I know you're not shy. Yes, sir.
Steve Justice, state of Georgia. I remember as a kid growing up and everything, that we had one way to get to space. And if we saw with the shuttle, if we had a problem with that one way to get to space, we were grounded. So now I'm seeing 4 systems in front of me, which has tremendous capability. So of course we lose one, maybe next 3 keep flying. But the real question to me is, space is a big place, but is space big enough for 4 human-rated systems? How are we going to maintain those at a rate that keeps all 4 of them viable?
Great question. We'd like to take that one. Todd.
So I'll start with mine. We differentiate.
Is that because you're the biggest system?
Well, we differentiate because we're not playing around in low Earth orbit and focusing on getting to low Earth orbit with humans. Our focus is further out and beyond, and so we'll take ourselves out of the run and let the other 3 tell you why they all think they should.
So I'm on the other side of this table, so I'll go the other way. And, that's the bookends here, but I think a more serious answer is, from our perspective, we looked at it and said, to make our vehicle as utilitarian as possible, to create as many missions as possible from the structure. We don't have one ship in the Navy, we don't have one plane in the Air Force, and that's a lot smaller area to cover than space. So when you think about it in those terms, there is a need and there's capability to have more than one type of system. Our approach was we like to actually call our vehicle an SUV, a space utility vehicle, so that it can do many things. It can do transportation, it can do construction, it can do repair, it could potentially go out and become an independent research facility. And by doing that, we open ourselves up to missions that perhaps aren't contemplated in clients beyond just NASA, and that's how we approach the client. And we have no designs to go beyond LEO, so it keeps our focus in on how do we horizontally expand in the environment that we're in, leaving the tougher, old hardware off to NASA and Orion and SLS to take us to the next destination.
Anybody else want to add their 2 cents?
Yeah, I think it'd be hard if you look at the next decade, sustaining 3 different systems at an affordable launch rate. But I think a lot of it's going to be driven on destination. If you look at our 3 systems, they're just transportation. To really utilize these systems effectively, you need additional destinations. And so I think all of us are looking at how we can partner with other groups to establish new destinations. But that's going to be the driver.
So I think you hit on some really good point there, which is that the importance of having a mixed fleet, to have some, we're all engineers, so we all understand the concept of redundancy, and we all saw how useful it was to have the opportunity to service the space station with Soyuz when we had to ground the shuttle fleet for a while after Columbia. So clearly having that capability is a very good thing. Dissimilar redundancy is something that every engineer loves, right? But at the same time, there's another reason why it's important, which is as we try to work on a commercial model, the commercial marketplace works best when there's competition. And no consumer ever does really well when they're subject to a monopoly. And so it's really in the best interest of NASA and the best interest of all of us to continue to have competition as we progress for that economic and reason as well as the engineering reason. So how can we do that? Well, it's going to be difficult because, well, let's be honest, we know what the commercial crew budget is going to be, or what the ballpark is going to be in. And we're about to step up and really start doing big things, flying test flights and then offering the first few servicing missions. That takes money, and realistically there's not enough of that to go around. And so we might solve this problem of this table being a little too small to contain all of us up here at next year's AIAA meeting. But I just hope it doesn't shrink too much, because keeping that competition is really important for a lot of reasons.
So on a related question, I'd like John, Garrett, and Mark to take this one. Very much related to that. Talk about whether you believe there is a commercial market for human space flight in the next 5 years beyond selling to the U.S. government. Clearly, even though we have commercial-led programs and government-led programs seated at this table, they're all heavily dependent today on the government market. So talk about your perspectives on the commercial marketplace over the next 5 years. And Mark, let's start with you.
I think there's a couple ways to look at it. Perhaps the traditional way would be to say, is there a market for some type of tourism, and that's not really where we're focused in on. I think the larger market, and perhaps more interesting market, is the other country market that are out there. There are many countries that are capable and interested in doing space, but don't have these infrastructure, the systems to be able to offer a space program to those types of countries, and human space flight programs in countries, I think, is a market that hasn't been seen yet, and one that we're certainly interested in. And I think the other part of that is the ability to do real research in space. If you can't get on the space station, a lot of fortunate people are on there, but there's a limit to how much work can be done on the station, what kind of work can be done on the station. the ability to do additional types of work independently of the station is one that I think is a market that human-assisted or robotic is something that is a good market in the future.
Garrett?
Yeah, so I think as well, we're also interested. I think you're that's a very good statement there. That really, instead of thinking of it as space tourism, probably the bigger market is other countries and other large institutions that might have deep pockets that be interested in doing things in space. And so I think that's where hopefully we'll see things go. But it's very difficult to predict exactly how big that market might be. You can look at some of the work that has been done before in space tourism and say that, every time Space Adventures is offered a seat up on the Soyuz, somebody's bought it. So we know there's at least that amount of demand out there on the part of tourists. But as far as the sovereign nations that might be interested, it's something that we're definitely interested in, and we'll pursue that revenue if it manifests itself. But it's not something that we are using to close our business plan, because it's very hard to put a number on it.
John?
Yeah, I agree. I mean, our parallel is the government's vision when they set up airmail that really helped the commercial airline industry take off. And NASA and the government had the vision to establish the infrastructure here and pay for the preponderance of the development costs on the commercial crew. And that was really the only way that I think the industry could close the business case, is having the government establish the capability, which would then let other markets emerge, because it wouldn't be so cost prohibitive. So there is interest out there, especially from other countries that want to be spacefaring nations. And I think they're waiting in large part to see what happens this month.
I think it's interesting too, if you look at other industrial analogies, when in the early 1980s, when the world was shifting from solely mainframe-based computers to this new thing called a PC, and you watch that whole fight go on. At first, people thought, who wants a computer? Why would you want that in your house? What would I use that for? And then a little application called VisiCalc, which spawned Lotus 1-2-3, and the business area just took off. Nobody expected that. It went, and then it matured, and something called Apple came along with a friendly computer, which I've been an owner since that point. And you've watched that change our whole world to these things in our hands. So I think it's interesting. You can't predict where these kinds of markets are going to go, but it is a huge marketplace. I think this is going to be the subject of a lot of conversation, particularly as we move closer and closer to flight. To that extent, let's go to Todd and Mark Geyer. Is there anything further the government could or should do to enable commercial space? Is there anything the government could or should do? So take off your SLS Orion hat and think a little broader hat on this one, that could or should do to enable more commercial space.
Yeah. I think it's absolutely true, and I think it's critical too. We kind of set up this dichotomy ourselves, which I don't think is really real, that it is absolutely true that cost and affordability is as important for SLS and Orion as it is for the low Earth orbit missions. And it's essential that in both cases, we are constantly looking at ways of getting these missions done cheaper and as fast as possible. Now, we don't have, given the risks on these designs and the risks to the development, sometimes we don't have all the same tools, but we got to be breaking some things up and looking at ways of doing that. So, including some of the things we've done with breaking off pieces of this work and making it fixed price, and look at ways to get a little more competition in some of the downstream efforts. But I would think relative to, our particular contract is set for development. In production, we're still looking at ways of doing that. But I think for the long term, I look at Bill Gerstenmaier's examples on Space Station, because there will continue to be systems for long-term exploration that you will need in long-term habitation and other things, exercise, water generation. And I look at the examples that Bill has done on Space Station, for example, in the Sabatier, where he basically The contractor took some risk and he buys water from them. I think those are examples of systems that you could certainly test out on station and then continue that into exploration systems. So I could see that as key pieces, and again, exploring those on space station and then pulling them into our systems. So that'd be my example.
Todd?
So I'll look at it maybe from a very big picture view and then maybe down to a detail level. But writ large, NASA built an International Space Station, and it's an outpost that needs to be supplied. And we've essentially created the beginnings of a market for that. And so the Sabatier being one, but not just water, but everything. And now what about the crew and getting them to and from and creating that service industry to supply it. And so I think we have kind of done that and are enabling the commercial crew and cargo through that aspect. If you zoom all the way in, I toured around some of the facilities at Marshall the other day just to see some of the stuff that's going on SLS. But interestingly, I heard a couple of different times some of the interesting areas that we play in, like selective laser melting or self-reacting friction stir welding. I'd be talking to a technician who is working on kind of a state-of-the-art aspect of it, and they would say, and I won't say which company, but you know, we had a telecon last week with one of these companies, and we're comparing notes, and now in one case it went where we learned something from them, the other case it went the other way, where the actual stuff where we're learning things, we're sharing that so that they can be more successful from the bottom up. And so we actually have organizations that didn't exist 3 and 4 years ago at most of the major NASA facilities that are actually set up to be as easy as possible. I know it's difficult to work with the government sometimes, but to create that direct line to the hotline to somebody who knows something about that area and can help resolve those problems and move more quickly into a solution space. So those are two, and I think we ought to continue that as well and continue to foster that.
Steve, if I could, I'd like to.
Please, Mike. Yes.
So at Kennedy, we've got this concept of a 21st century launch complex. We're trying awfully hard to create what we call a spaceport. And really the purpose for that is to enable the commercial space. And we're doing an awful lot of things. I mean, we're a long way from Kennedy, so you may not hear as much about them out here, but we're making our assets available. So Garrett talked about Pad A, right? So we have two launch pads, Pad A and Pad B. We use them through the shuttle program. For the SLS Orion program, we have a near-term need of one launch pad, and that's Pad B. So we have a 20-year lease with SpaceX to use Pad A. So that's a great opportunity where we had a significant investment. We no longer had a need for the asset, and SpaceX was able to use it. And it's really the same with a lot of the assets that we had from our prior programs. We had the 3 OPF bays. So you heard John talking about doing the processing in OPF3 when he initially started for the CST-100 when he kicked off his part. And then Mark is he's got some. We have a tile production facility down there where we make the tile and the fabric that coats the spacecraft. And Mark is talking to our folks about can we make tile for them as they move forward. So we've got great assets. The Pad A, the 3 OPFs. We're getting ready. It's not quite there, but we're talking about can we make one of the VAB high bays available to commercial space. So, today we've got these 4 high bays. We don't have a need for all 4, at least not in the near term. So we're looking at, is there an opportunity for commercial space to take advantage of one of those high bays? The shuttle landing facility, the 3-mile landing strip that we had, that we obviously needed because the shuttle landed horizontally for SLS and Orion. We don't have that same requirement. So we're looking at, are there folks who can take advantage of that shuttle landing facility? And it turns out there are a lot of people who are interested in horizontal launch and landing. So at Kennedy, we're working really hard to make assets available. We're also starting to talk about can we make land available for people who want to take advantage of the strategic location that we have. And then similar to what Todd was talking about, sharing the experience. We've got a workforce who has a lot of expertise in launch operations, both on the NASA side, which we try to make available to our commercial partners, but also through our contracts. And so we're working new business processes. We're trying to do things like what we call third-party contracted work, where commercial space can actually leverage government contracts to get some of the services or some of the knowledge that they might be able to take advantage of as they move forward. So at Kennedy, it's really been a point of emphasis, something we've been working really hard, and I think, as evidenced by the gentleman I'm sitting here with today, they are taking advantage of it already.
Yeah, we had a personal experience. I had a personal experience where we had put in about $90 million worth of friction stir welding tooling at Marshall, and it wasn't being used, and we're able to go out and leverage it. I mean, that was sitting there. There's a lot of that capacity that has been invested in that's there. I think that's a great add, Mike, in terms of the facilities, the assets, the land that can be partnered with, and it's part of, to me, this maturation and evolution of NASA from everything driven by a government mission to now enabling other markets and other people to play in this, which is, frankly, the reason I got in this business was I like to watch, obviously, the Apollo Saturn flights, but I remember what was on the back of the vehicle that took the crews to the space station in 2001, Pan Am, right? That was where we were heading towards, and I think that's the kind of vision. If you look at commercial and government, they've always worked hand in hand. They haven't worked against each other to be successful. So this is a great evolution of where we're going.
And Steve, I left out one other thing.
Please,
Not
yeah.
to keep going, but we also
Good.
we have an appropriation called 21st Century Launch Complex, and that's a funding line that enabled us to upgrade the infrastructure that we have at Kennedy. So it allowed us to upgrade utilities, communication systems, do things like upgrades to the range telemetry systems over on the Air Force side. So again, very specifically targeted for helping the broader space community.
Great. All right. Jeff, I knew you would have one, so let's go to the audience. And Jeff, you're the first, and I've got you a second.
I'm Jeff Bingham. I'm an old retired guy. And this kind of falls on the question.
You're never going to retire, Jeff. I know that. Yeah.
I don't receive. Other than the hairline.
Yeah.
The question is sort of on the commercial side again, and that is, as you guys are all talking about the market, I didn't hear anybody specifically mention the fact that we've got a big space station up there, and 50% of it is available to commercial, non-government use. In fact, NASA, with all of its needs for exploration and testing and development, is limited by law. I know, from using any more than 50% of that vehicle. So you guys not only are taking crew out to help expand the crew size, hopefully, but what about, is there recognition that there's great potential for research capacity being expanded far beyond what we have now, so that even the commercial resupply contract you've got now is inadequate, so even the cargo is potentially increased as well as the crew involved.
All right.
No, I think it's a great idea to try to increase space station utilization. I think that the vehicles we're developing are uniquely suited to and capable of doing that if it's so desired. One of the things is that I know that all of our vehicles can transport more than the 4 astronauts that NASA wants to rotate as crew. We can all carry more than that. And so one of the things I'd like to see is NASA really think closely about what can you do with those extra seats. And one possible thing is, like you're describing, is we can fly researchers. We can fly principal investigators and let them do their science in situ on board the ISS, rather than, which is where I think you really fully utilize a human platform for science research. If it's all just payloads that go up, get stowed by silly astronaut technicians get their filters cleaned and cartridges changed periodically and then sent back down, well, you're not really fully taking advantage of the human in the loop. If you instead create opportunities where you can send the scientists themselves and let them fiddle around in situ in that environment and react in real time to their observations, that's where I think we potentially could get that real eureka moment that could lead to a Nobel Prize or something really amazing in science. So I think that we are creating the infrastructure to allow something like that. There just needs to be a will to step out and do that.
Yeah, we've had early discussions. I think from a NASA perspective, they're waiting until this contract's awarded and they understand who their providers are going to be. And then I think it's imperative that we go establish and show the benefit to NASA of adding this additional burden on them, right? Because there's got to be a benefit to NASA, and there's got to be a demonstration that we can do it without impact on what their primary mission is. But I think they're willing to discuss it. It's just waiting until this next round, and you get closer to the point where you're actually going to be flying missions to it.
Mark?
I certainly agree with these two guys. I think from our perspective, one of the reasons we developed the vehicle we did was exactly for that purpose of bringing home science in the most benign, fastest way possible, not just taking the crew back and forth. We're home from 6 to 10 hours from the space station to a runway, and that's a wonderful thing for crew, and particularly for crew who may need to get home quickly. But it's also a great thing for the experiments, being able to manage that at less than 2 Gs coming in. And we think having that capability will accelerate the science side of what's going on. We recently also talked about even going further than that, working with the city of Houston of potentially landing back in Ellington as a field. And interestingly enough, the reason I brought that up is that probably the #1 group of people who called me about it were scientists at the Texas Medical Center, who were so excited about possibly actually getting work coming back home from orbit to a runway in their city where they could pick up those experiments and move them quickly. And I think what we're all talking about doing is when we increase that capacity, we're going to see that the ability to go beyond just the crew and the cargo to keep this crew alive is really going to be, perhaps in the long run, the most important thing of this program.
Question?
Andrew Nelson from Mexico. So, if it was up to me, I'd make sure all three of you at least got to IOC, so there could be a real proper commercial competition. Hopefully, people who have friends back on the Hill could certainly push that point. But it does beg the question that what's going to happen after the next round? If there's a down select of 2, or God forbid a down select of 1, it would be terrible for the American taxpayer. What are your companies planning on doing? Are you going to continue to move forward if you're not part of the final 2?
Our focus has been completely on getting ready for the next round. Yeah, but I've said before, we would stand back at that time and see if you could close a business case. Right now, I think that'd be very difficult to do, to try and take the burden on of the full development cost with an uncertain market in front of you.
Yeah, I think we're all going to be in a position of having to assess. It's not just whether or not we get chosen, it's the process by which that choice is being made. Is it economic, for example? If it's only economic, if there's only room for one company, then that's not a technical decision, that's not an architectural decision, that's a budget decision. If on the other hand it becomes purely technical and there are faults in somebody's program, then that, I think, brings a different solution to the table. At least from our perspective, we are advancing well enough that we have an opportunity to make that choice. A year or 2 ago, that wasn't there. I think we are now at a place where it is possible to continue. I'm not saying we can or we can't. That's going to be something we assess, but at least there's a possibility of doing that. And we get asked this question a lot. I'm sure all 3 of us do. I told the story not too long ago that we're based in the Denver area, and one of the reporters asked Peyton Manning what would he do if he lost the Super Bowl. And Peyton just looked at him before the Super Bowl, obviously. We had a little bit of a problem there. Peyton just looked at me and said, there is no beyond the Super Bowl. And, we are gearing up to do what's in this competition right now, and we're not stupid. We've been laying the foundation for other potentials later on. And the longer it goes on, as you said, to take it to a next level or take it through CDR or take it to first flight, then the companies who are not chosen have an opportunity to potentially continue on. And that, I think, is even if you don't have competition within the NASA commercial crew program, you could have competition within the broader scope of LEO access, which is perhaps even as important as the NASA program.
Garrett?
So, yeah, we're in a little bit of a unique situation because the whole reason our company exists is to take humans into space. So we're not going to give up on that mission, on that vision, no matter what happens. And we certainly hope that we can proceed in partnership with NASA. We would be nowhere near where we are today if it were not for the partnership we have with NASA that goes way back to the beginnings of the commercial cargo program. And so we benefited tremendously from that, and we really, really want to continue that way. However, we're not going to stop. And in fact, we're already going ahead. As our teams wrap up their CC-ICAP work, they're not sitting idle or moving on to other projects. They're continuing to work on what would be our deliverables and our work to do under TCAP. We're not letting our foot off the gas one bit. In fact, we're not only today expending engineering resources to do work that would be for the next phase, but we're actually bending metal for stuff that we will be using in the next phase. So we're going to press ahead. It'll be different if we no longer have this partnership. It'll obviously there'll be a lot less resources, and we would have to bear all the development costs. So that will change things dramatically, no question. But we're not going to stop.
All right. Let's talk a little bit more about, let's pull on this transition to commercial and government-led human spaceflight. What, in this growing commercial environment, if you will, that we're in, how do we ensure safe and reliable space travel? That's been something that's been talked about a lot. The NASA Advisory Council has talked about it. The ASAP has talked about it. Let's get your perspectives, and let's let this one go with everybody, because I think it applies to even the government-led systems that are up here. And Todd, let's start with you and just walk down the table.
So safe and reliable. I think we're actually coming at the problem from a different direction. It's no secret that that we get somewhat obsessive compulsive about safe and reliable on the NASA side, and sometimes that can play against affordable and sustainable. And so we still have to be safe. If we're going to do the kind of missions we're talking about on an SLS that are strategic, we want to have a sporting chance. And by sporting, I mean when we did the moon mission, or the first time John Young flew on the orbiter, you're talking 50-50 kind of stuff. So we want to be, we don't want the rocket to fail on these strategic missions. So that said, we can't keep pounding everything completely flat. And so when we first stood up the program, we came up with what we call our norms, and we came up with 10 of them. And our chief engineer stood up and said, "I want one more," and it was, "I pledge to do imperfect work." And I will tell you that caused a firestorm, first amongst the team that was at the offsite, and then when we brought it back to the rest of the center and they had a chance to see it. But when of course we want it to work and we want it to be safe and reliable, but we also have to know when to stop, when to stop obsessing over problems. And so for us, safe and reliable won't be, I think, our biggest issue. It's going to be knowing when to stop pushing the design and the analysis, and put our pencils down and push the go button. I can remember Von Braun talking about having a sense of daring. I remember when I applied for my first senior executive job, the announcement actually said NASA seeks people with a sense of daring. And so if we're actually going to do this, if we are actually going to go and push out beyond the moon and try to go to Mars, it will take daring. It will not be something that for the timid. We will have to take some risk, and so that's our challenge.
Mark.
Yeah, this is a really good one. This is very complicated. I would say maybe, Steve, I might take exception with your categorizing us as government-led. I mean, there is a NASA program manager for commercial crew, Kathy Leaders. You might know Kathy. She's an outstanding leader. She struggles with these questions of oversight, right? You can imagine the NASA side, exactly. JSC Kennedy, it's led out of Kennedy, and discussions about exactly what oversight is essential. So both programs are NASA-led, so let's be clear on that. And Kathy struggles mightily with oversight, what is sufficient, both engineering and safety, because both of them are a big deal. I can tell you that I personally, she and I talk quite often about this, because we reside in the same zip code. And while there are differences in risk level for the mission Orion is on, because you can be 10 days away, right? You can't get back to the surface of the Earth very far. There's a lot of issues that happen in deep space that don't happen in low Earth orbit, and you have a long way from getting home. There are different risk levels, but for the risk levels that are the same, it's my opinion that I don't know why the safety level is different between Orion and these other spacecraft. For example, entry and landing, right? Very similar parachutes. Why should my oversight level be higher than on these other spacecraft? So I want to be clear. I'm not saying Orion has got it right, or that we don't need to be thinner. I believe we do need to be thinner. We do need to be backing off, and Todd said it right. And I have these very good discussions with engineering about every dollar we spend watching Lockheed is one less dollar Lockheed is building something, okay? It's very important, and my chief engineer and my CSO, they understand that. But this is a very difficult, very hard question. What is risky enough is not a black and white question, right? It's very complicated, and when we say we want to take more risks, the first part is you have to understand your risk, first of all, which means you have to have some level of understanding of the vehicle. The question is how much of the understanding has to reside in a guy or a woman with a NASA badge, because the contractors also, they're on the line, their companies are on the line for these spacecraft. Lockheed, I can tell you, is extremely dedicated, and their team is extremely dedicated to make this work. They understand their corporate reputation is on the line. So they have a lot of, in a sense, insight and oversight on the risk themselves. The question is how much does NASA have on that? So I could say there is no black and white answer, but I am pushing on our team pretty hard to get to the minimum. The beauty about EFT-1, so what kind of techniques can you use? EFT-1 is an unmanned test flight. So our oversight level, especially on the test flight itself, is extremely limited as far as the number of engineers watching certain systems, and especially on the integration with the rocket itself and that integration part, because I don't want to be a rocket guy, right? I just want data on Orion, so I'm not paying for that. So you can use those early test flights to skim the team off and then add it back in based on specific risks you saw on your test flights. That's one technique. So I would just say this oversight thing and the risk level and safety is something that applies to all of us. It is not a black and white thing. Last thing I would say, this commercial, moving into this commercial market is not the first time we've had to deal with that, though. Any engineer or program manager that worked on Space Station remembers this exact discussion about insight into Russian hardware, right? How much do we need to know about every M&P standard, about every fracture, what they do on fracture control? I can tell you there was a huge debate. So NASA has gone through this before, and we need to use that experience as we're working with our new partners moving forward. So it's very complex and probably one of the most important questions that we're dealing with.
So Mark ran the Russian segment on Space Station, and I was his deputy. So we've actually been through this together. We called it depth of penetration.
And why do the fracture control boards always the ones that come up? That's always fun.
So is M&P, guys.
Mike?
Let's see, I guess just two quick thoughts to add. The first is, and we talked a little bit already, but just sharing knowledge. We're working on a lot of common problems. In some cases, the government has a lot of experience in an area. And so it's sharing the lessons that we've learned, whether it's emergency egress systems, whether it's landing and recovery systems, whether it's how we use tile and blankets to protect the spacecraft. All those are areas that we can share. And by the way, it goes both ways. Sometimes when we talk with them and say, well, this is how we've done it. We notice you're doing something different, and we have a conversation around it, a good engineering discussion. We learn some things. And so, on the one hand, we're sharing lessons that we've learned. On the other hand, we're learning some things because they are challenging the way that business has always been done. And so it's really valuable in that it goes both ways. The other, and Mark talked about having the right level of oversight. The right level of insight. We do have a NASA program. Kathy Leaders is the manager. Underneath Kathy, she has assigned a team of engineers, really 3 teams of engineers, one assigned to each of the 3 different CCI CAP teams, and they review the design documentation, and they review the hazard approaches, they review the standards documentation. They go through them very rigorously and provide feedback to the commercial space providers. So there is a lot of interaction, there's a lot of discussion, and I think in a lot of cases they are able to leverage some of the lessons that we've learned over time.
Garrett?
So those are some great words, and I'm not going to disagree with any of them except for maybe it's about the OCD thing. I think a little bit of OCD is good, and that's I'm a list maker, and so I think as far as the NASA standards and as far as requirements and safety standards, we fully expect to have our feet held to the fire. Just like they were when we built our cargo vehicle. We didn't get any free passes when it came to flying our cargo Dragon in proximity with the space station. We had to meet every fault tolerance requirement, and we had to go through a very rigorous inside and oversight process. And we expect that now to apply to all phases of flight, not just flying around the ISS, but when we're talking about putting people in there before T0, it's going to apply to everything. And so we fully expect that level of rigor, and that's a good thing. But one thing that I think I would add to the conversation that has been we just heard is that we need to make sure that in the name of safety we don't preclude continuous improvement. It's really important that we listen to the vehicle and we respond and make things better. And we can't make the threshold to making an improvement so high and so costly that we just live with it. Because if you look at the two catastrophes we had in the shuttle program when we lost our two flight crews, it wasn't because we were changing things willy-nilly and being too cowboyish. It's because we failed to fix something. In both cases, it was something that the vehicle was telling us, something we knew was wrong, but we didn't. But we made it so expensive to fix things and so hard to overcome that threshold that we just live with it. Whether that be hot gases going through O-rings or foam coming off of external tanks. So it's hard. There are some other cases where we said, oh, this is clearly a safety of flight risk, and we're going to do whatever it takes to fix it. And I remember feed line cracks and booster balls and all kinds of things like that where we pulled out all the stops. But it's really, really hard to know with something as complicated as a spacecraft what the thing is that's going to kill you. It's really, really hard to know. And what we need is an environment where we are not accepting any deviation from normalcy, where we are aggressively pursuing anything that's wrong with the vehicle and fixing it, not just living with it. And we got to find a way to make that work in the environment that we all live in.
That sounds like a lot of CABE in your talk. Columbia Accident Investigation Board, for those of you that don't know the acronym, and that's some powerful words. John?
Yeah, this one's always interesting for me because I spent a long time with NASA and then I've spent a long time with Boeing, and the difference in mission assurance and safety between the government and the contractor is really, really very small. To me, it comes down to making sure you have the right culture and the right processes. And even on the Boeing side, with military aircraft, commercial aircraft, losing an aircraft and causing the loss of lives is never acceptable. And so you drive in safety across every program. And safety has to be part of every technical decision. And then from a process side, you just need to make sure you've got the right level of rigor in your design process and your certification and verification and your ongoing operations. And you got to have, no matter what badge you're wearing, you've got to have the right level of insight and checks and balances organizationally so that you can ensure robustness in your overall mission assurance process. That said, with NASA as a customer, it is imperative, from a taxpayer standpoint if nothing else, that they are a smart buyer and they have the insight into your overall design and operations and safety approach. And I think that balance really provides an effective safety culture.
Mark?
Maybe we can make this a little participatory. How many of you all flew here, just by hand? Virtually all of you, right? And we do that because we believe in a regulatory body called the FAA who certifies airplanes. We were going through the same process here. There's going to be human safety standards set up. It's binary. If our vehicles don't pass that safety standard, and it is very comprehensive and complex, you don't get to fly people. If it does, you do get to fly people. And that safety standard is being developed by NASA with a lot of other people involvement, including industry. And it's no different than the safety standard we set up for airplanes. If you don't get certified by the FAA to take people for pay, you have an experimental certification on your airplane and you don't take people for pay. If you do, then it's presumed that you've met the safety standards that are necessary. And whether or not it's my vehicle or these two or Ryan or anything else, that safety standard is going to be set up and we need to meet it, otherwise we don't fly. And once that standard is set up, there's a presumption, and if you meet that really high bar and you do get certified for flight, then you're safe for flight. You have to maintain that standard. You have to maintain the processes through it. And that's something I think people should realize. There has not been a human spaceship that has been certified to that standard to this point. This is really a super effort by NASA and a lot of other organizations and agencies to create that highest level standard possible, raising the bar for all of us. And if we pass it and are certified, then that is an effort to say that we've put in the proper safety procedures and the proper control procedures and the proper understandings of what to do if there's an issue. And I think that's the way it should be. It's the way that we've been able to build such a great airline industry.
Having a bad day is in nobody's best interest. Nobody's best interest. Question?
Okay, so we just went over the topic of safety. Just to cover what Mr. May said, you said we don't want the rocket to fail on strategic missions. I want to replace the word rocket with human. We don't want the human to fail on strategic missions. And then what Mr. Reisman said, looking at a spacecraft, it's hard to tell what's going to kill you. Looking at a human, it's hard to tell what's going to kill it. So I want, just taking into account the human spaceflight paradigm, what considerations are being made to acknowledge the fact that the human is actually the most uncertain part of the entire equation? What factors are being taken to make sure that the human is safe psychologically, that we're not suffering post-traumatic stress disorder, sending people out there, and do we have to lose a flight crew to say that that's a mission failure, or where's the line end? So that's my question. What's being done to assure that the individual human safety, not necessarily the vehicle safety, but like the human safety?
So I'd like to start with one of us that's actually flown in space for this one. Garrett?
Yeah, I understand that why you would ask a question like that, because you've met me, and so you would obviously have some reservations about that. So I could tell you that at least what we're planning on doing is the crews that will be flying in our vehicle as part of our contract with NASA are NASA astronauts. And the astronaut corps at NASA is very carefully trained, very professional, and the selection criteria is very rigorous. And so one of the things that we do when we select astronauts is we do subject them to psychological testing. And we also, especially as we entered into the space station phase of human spaceflight, we started paying more and more attention to interpersonal skills, leadership, teamwork, self-management, and that became part of our interviewing process. So we tried very hard to select people that were well qualified in that area, and then give them proper training and experience, and test them in strenuous cases. That's one of the reasons we maintain a fleet of T-38 jets, which is constantly being examined when the Budget Act comes. It's really important to put people in realistic settings, not just in a box in a simulator that no matter how bad it goes, you're going to go home and have dinner, but in real world settings and see how they do. And so we're very, very careful to make sure that we're selecting people. And then all of us, as we design our spacecraft, one of our key requirements is that no inadvertent operator error can lead to a catastrophic event on the vehicle. So we have to safeguard the vehicles to make sure that humans are imperfect, and when that day happens, when something imperfect happens, it doesn't lead to a catastrophic effect. So we work hard on that, but I don't know if I think I would take exception to the what was it, that the humans are the most uncertain.
The uncertainty equation on a systems engineering perspective, humans there's too many variables. When you're looking at it from like a mechanical engineering perspective, you could calculate those variables with a lot less error rate. So humans are a lot more uncertain. But the reason I asked this question was I wanted to hear stuff like what kind of suits are you guys using? What kind of state sensing are you doing? How is that helping to ensure safety?
Well, yeah, well, there's a lot we can discuss there, but I think that the weakness, as you're calling it, about the uncertainty in the human is exactly the human strength that the human brings to the reason you put a human in the loop is that adaptability and that ability to respond to something that was not predicted. So you got to take the good with the bad.
Anyone else want to take a cut at that one?
Yeah, I certainly agree with Garrett. A couple of other points for us. We too went in and said, let's put somebody in charge of our training program that understands. In our case, it was Steve Lindsay, who's been a 5-time shuttle pilot. But more importantly, ran the astronaut office for 3 years and had to understand how to make choices and who flies when and what's the criteria for what their physical and mental state is when they do that flight. And having that kind of leadership is really important. I think the second thing is that in our case, we've built in redundancies in the system. Our vehicle's capable of fully autonomous flight. So in the event that something did happen physically and catastrophically to the human pilots on board, we have the full capability of going into autonomous flight and the vehicle can fly itself home and land. That's the second thing. And I think the third thing is in understanding that we live in a world that is blessed by an enormous capability to do simulation, unlike anything else. Even when I started flying, certainly, and when we all started flying, the world has changed enormously in that regard. And we are putting a lot of effort into the most realistic simulations possible so that we can train and eventually weed out those people who aren't capable of making those reactions and go through really an overboard training program to make sure that not only the pilot or the commander of the mission, but even those who are participating in the mission understand what to do. How do you put the vehicle in autonomous flight, for example? How do you do that under stress and G-forces? And using those things, in addition to what Garrett said, I think we're building a safety standard that hasn't been seen before.
Todd?
Well, the other thing, I was thinking earlier, we did that, who all flew here in a plane. I would say, who all flew here in a plane with no pilot?
Yeah.
So even our most mundane, who got here in a car with no driver? You're going to need the people in there.
I don't know. And we're on the West Coast. The Google car is probably driving here somewhere. All right.
That'll be interesting when it comes along. The other thing I thought about is there's a website you can go to, and it recreates, it's kind of a dashboard of the Apollo 11 landing, and one of the things that's really cool about it is the heart rate of Neil Armstrong as he's coming down. And Mark talked about that rigorous training and how when we put folks in charge of missions like that, it's actually the human that is actually helping to make it successful. Or Apollo 13, where they had the innovation to reconfigure things. So you really try to turn that into the positive and use it to your advantage.
Now, I promise I did not plant this young man in our front audience, but we have a related topic, shameless ad for an AIAA 360 event tomorrow. It's called Unforeseen Events, Learning from the Untold Stories of Human Spaceflight Contingencies. We're going to have Dan Brandenstein, Crippen, and Colonel Greg Johnson, all three to bring some of their stories. You learn a lot when you go through those issues, when you go through those contingencies, when you have those failures and you have to deal with them. That will be in one room over in Harbor Room B, same time tomorrow afternoon, and I recommend that one to you because that'll get into a lot of interesting details of how that human in the loop plays a role. I had one last hand up in the room, and we'll take that one as our last question.
Greg Autry from USC. I just recently did a report for FAAST on U.S. national competitive advantage in human orbital markets, and the good part of the report conclusion was essentially that no other country has anywhere near the competitive advantage the U.S. has for the commercial market. One of the fundamental reasons is because we actually recognize there is a commercial market. But what you don't see when you look at this panel here is the fact that you've got $1.5 billion or more on this side of the room, and you've got these three guys fighting for a few $100 million. In fact, if you laid this table out evenly, John and Garrett would be sitting on Mark's lap. And I hear these folks talking about this to justify their existence as NASA by delivering value to NASA. The FAA does, or commercial airlines don't exist because of the value they deliver to the FAA. Research universities don't exist because of the value they deliver to the National Science Foundation. I ask you, is it possible we've got this backwards, that we should be developing a commercial market that generates revenues and tax income that will support NASA in the future? Does anybody that looks at the U.S. budget outside this room knows that NASA's budget is not getting bigger?
Any comments on developing a space economy that works and helps NASA grow along with that space economy? So they're playing a little bit.
Yeah, I think, so it's a great question. I think it gets back to what Todd said, you know, this market exists because the space station exists. Space station was not $20, right? And it was a significant challenge, especially when we added the partners, which was a huge part of the U.S. leadership. So when we're looking at, on this side, we're looking at investing beyond low Earth orbit to potentially provide a market in that region, right? And it's new, and it is much higher risk, and it takes much more energy to get there. So to me, that's the benefit we're trying to get, so that there's markets at the moon, or markets to Mars, or Phobos, or Deimos, or these asteroids. That's an investment that the United States, the way I look at it, is expending to create markets there, which will be much bigger than space station. Space station market is limited. So I think it's an importance to have both, because we need to not just have those destinations, but actually exploit the market. So I won't argue whether the current appropriations number is right. It's not up for me to argue that, right, how that should be balanced. But it doesn't surprise me.
Just so you know.
Yeah. So Jeff would agree it's not.
Hey, you were an authorizer.
But that wasn't my decision either. But it wouldn't surprise me that the majority of the money is on creating the new market, on the stuff that is hard to do that nobody else is doing, right? So I wouldn't debate the exact number, but it has surprised me that that's where you would spend your development money. Yeah.
Any other comments? No? Todd? Well, I think we've had a great panel. What I'd like to do now, we often don't do these, we just kind of sort of end them and send everybody on their way, is I've just been writing down some phrases and words as we went through these questions, and I want to just kind of go back through some of those, because I think it summarizes some really important points that came out of this. And we delved through a lot of issues, and I can't believe the 2 hours has already gone by since we started this. But clearly, an exciting 3 years is ahead of us that are going to set the stage for the next 20. We don't get these kind of opportunities very often, and they only come along kind of once a generation, and I hope they start coming along a whole lot more often than that. That's the reason we're all in this business to begin with. But under the category of enduring, some words I wrote down: inspiration, caffeine, shiny toy, discovery, a need and a hunger to explore because it's there. Under continuity between administrations, it's up to us. We have to deliver and do what we said we would do. And adaptability and flexibility of both the programs and of the people. Under this technology push versus pull discussion, it's about the mission and the driving need. And what we're doing today is we're developing the infrastructure needed for the later apps that will ride on our infrastructure. Under supporting multiple systems, both LEO and beyond LEO, not or, and, we don't have a one-ship Navy nor a one aircraft Air Force. We're developing space utility vehicles, and competition is good. Under market and the commercial market and where it may go, we're focused on non-spacefaring countries, industrial research, but it's hard to predict, but there are analogies such as airmail. On the role of the government, more competition, more markets, knowledge sharing, and facilities and asset sharing. Under the space station for commercial, utilize the capacity that we have with the unique capacity, and we have humans in the loop in space. On moving forward, it's really hard to close the business case because the ISS is obviously a big driver in this current market space, and as Mark just mentioned again. Under safe and reliable, I wrote the most down under this one. Perfection is not achievable. Daring is required. Adaptability is important. We don't need to have two different standards. We need to be continuously learning and continuously improving. We need to listen to the vehicle. We need to constantly watch and nurture our culture, and it's largely about balance. I think these are some really important takeaways from today's event, that these fine leaders that we have here today who are really a part of our community taking us forward. And I'd like you to all give them a round of applause.